Okay, so last week we created a controller and we said that it would be nice to always have something that runs from the word go. So when you start with a new MATSim project, you should be able to create a scenario or load a scenario from a config file, create the controller, set it up in terms of how long it should run. If you want to have an overriding module, you would do that. You would create your own module, and inside this module, you'll do all the magic that you want within the MATSim washing machine to actually happen, and then you run the thing, and it should always run. And then what we did is, whenever you create this module, you can create a constructor, meaning at some point you will create this thing, this module, but it will only be installed at a specific point in time, kind of at the simulation startup. And what I want to do here is just show you two things. What we did the last time is we said that in MATSim they've chosen to go this Google Juice route, whereby you can inject things, which basically means is you throw something in the air, and during the simulation run, one part of the code will catch it where it actually needs it. And there are certain things that you can inject in this way. And there's already methods on the controller that actually allows you to bind, and that's kind of the verb that they use for this Google Juice framework, is to actually say you bind something to this controller so that the controller knows where all these things that are in the air, that they are currently in the air, and where to actually get them from when they actually need it. So one way of doing that is to actually say, right, add a controller listener binding. So what we will do here is we will bind specifically controller listeners. So these methods are not part of Google Juice. These methods are programmed in MATSim. So they created these bindings, and then there's a method that says to, and now you need to say, what do you actually bind it to? And the two main things that you can do is you can either bind it to some class, or you can bind it to an instance. And I want to talk mainly or link in terms of what we did last week to this constructor, this to instance. All right, so last week we said we just bind all our controller listeners, and these controller listeners were nothing other than just writing little log messages for us so that we can see where about in the MATSim machinery this is actually being done. Right. So there's a startup listener, iteration starts listener, a shutdown listener that we've created, and these are all the listeners. Now there is a constructor that you can actually construct an instance on this thing. So what you now need to remember, maybe just if you can relocate to a place where you can watch the board, is we created a class here. But this class is just an abstract thing, a piece of code, and it may not be able to be instantiated or created an object of. So in this object-oriented worldview we actually have is you can create multiple things of this class. Right? So in our case, the class is called all my controller listeners. And it is a class. So what we've done now in that code specifically is we said, all right, there is this thing called a controller, but we've created a loose couple, if you want to call it that, between the class and we've bound it to the controller. But an alternative, so what will happen is this class will only be created, this all my controller listeners will only be created when it is needed. Right. The alternative is, I know I want to create one of these things, a very discrete, real instance. So I want to instantiate it. I want to build one of these things called all my controller listeners. And now it's an instance. I've used its constructor to create a physical thing, which is this container called all my listeners, and I can bind that to the controller. So it depends on what you want to achieve, and these are these weird and wonderful things, and there's always more than one way to get stuff done. And which one is the right way? I actually don't always know, but hopefully I'll be able to give you an idea just now. All right.
So just to clarify, the inject is like saying we're not going to use the find that all my controller listeners, we just throwing it in there, and then the controller uses it when it needs to.
The controller knows about these things, but these things are bound to the controller. This one and this one. It's bound. Somewhere else in our code, in other classes, that's where we will put the @inject, where we actually need the stuff. So what the controller in this case does, it just has all these things that are bound to it, and when this is needed, it will throw it into the code where it actually needs it.
Oh, so the controller is
the controller. So that is why we typically use @inject the scenario, for example. Because remember, the scenario is inside the controller. And the controller says, you need the scenario? There it is. You can inject it into your code, and then it is available to do whatever you want to do with your so then you can use the scenario because it's been injected. But where does it come from? It was bound to the controller at some point in time. Either just the class or the instance. Depends on which one it is. And in the case of the scenario, it must be the instance because I want that real container, the scenario. I'm not creating a new scenario on the fly. I actually want to create, or I want to get my hands on the real one and only scenario. So in this particular example that we've done here, we can do the same thing. We could have also said, seeing that we've already, got this line of code here. So that would be one way to bind all my controller listeners to the controller. By actually saying bind to, and you just specify the class. Done. So it's kind of this loose coupling that says there is a class. If you need it, create an instance for yourself. Or what we can do, which is sometimes necessary, is we create a specific instance of this all my controller listeners, and what we do is we then bind it to a specific instance. So there we've used just bind it to the class. Here we've created an instance, so we can actually now bind it to a specific instance. So here it's 2 instance versus just 2. And the only reason why I found that this is necessary, or where you want to bind it to the instance, if there are some parameters in here that you have to set first. For example, there are certain parameters you want to set: the length of the vehicle, or the default number of passengers, or how many doors are there on a vehicle, or the maximum speed of a vehicle. You want to set that up in this class. And then this instantiated class you then pass to the controller to say, and use this one. I don't want you to go and create a new one. I want you to use this specific one. Does that make sense? Okay, so that's the first part that I wanted to just talk about. So these two things, that one-liner and this one, will at this point do exactly the same thing. The difference here is now we've created it, and it's this specific instance, AMCL, that will be used, whereas this object we will never be able to get our hands on because the virtual machine will create it on the fly when it actually needs it. But in our case, there's no difference between the two approaches.
Sorry, so in general, which is the one that's used the most? Which cases?
I don't think there's a general case. It depends on the function. Kind of form follows function. You've got both approaches because both have their use cases. And I'll show you just now when you actually, mind you, let's carry on to the next thing. So in MATSim, in the washing machine, let me see if I can just get that. Let's use this one. Right, so in this washing machine, what actually happens is we don't create one scoring function. We create a scoring function for every individual. And that happens every iteration during the scoring phase. What this washing machine, what the controller does, it actually says, here's a person, I want to score your plan. Here's a scoring function, score your plan. Right. Or when it kind of works through the events and it actually does the scoring and the events come out of the MATSim, it creates new scoring functions all of the time. Right. Now, how do you tell the controller that an individual must get a very specific scoring function? There's this wonderful thing that's called a scoring function factory. And the class does what its name implies. It is a factory that produces scoring functions as and when required. Does that make sense?
So the factory is almost like a class written. Every time it creates scoring functions like instantiating.
It creates a new scoring function and says, for that person, there's yours. For this person, there's yours. And that's the value of something like MATSim, is you can create a custom scoring function per individual. You can go into into the scenario and say, tell me the age and whether this person is working or some other attributes, and say, based on these factors, I want to give you an elderly scoring function factory, or a scoring function. So use that scoring function factory as opposed to a school-going scoring function. So you can literally create unique ones if you want to be that sophisticated. All right. So what are these things that we can actually bind? Let me just delete these. Let me leave them there for now. Carry on with the rest. All right. So you'll see that on this controller, one of the things, and why they don't have a mind you, probably it actually makes sense. So in the first lot, remember we're inside the abstract module, and what you actually have available, if we say add controller listener binding, I can also say this dot add controller listener binding. This is actually the controller that you're actually adding these bindings to. Right. So what add controller listener binding means is you can have multiple. So you can have one and add more. So you can have one that checks, in this case it's called all my controller listeners, and there's another one that does the statistics, and there's another one that does a different scoring, and you can add many of these controller listeners, as many as you want. But some of the things are only allowed to exist once. And when you bind it, it overrides everything that has been previously done. So then it's not an add control or what adds some binding, it actually overrides it. So that's where you will see this, for example, this dot bind. So there you will see that and these kind of methods that start with bind actually means there can only be one of them. And there you have a car travel disk utility factory. You can have an events manager. There's only one events manager that is allowed in a controller. It handles all of the events. You can add a variety of listeners to it, but there can only be one manager. You can have a least cost path calculator factory. You can have one MATSim, but only one MATSim running at a specific time in MATSim. And there's the one that we will work with now. Bind scoring function factory. So there's only one. There's only one scoring function factory that exists in any one MATSim run. And if you want the scoring function factory to produce different scoring functions for different people, you'll have to program your own one and add it in there. Right, but as a factory, there can only be one in a MATSim run. And that's what we're going to work with now.
So there's the default scoring function factory that when we run with all the default values, It just does.
It just does, yeah.
And when I change stuff in the config file, so you know there are values in the config file, so minus 6
It overrides that. yeah.
Okay, so then does it inject that into the scoring function or create a new scoring function factory?
No, it just adjusts the parameters of the current scoring function
of the
factory.
default scoring function.
Yes.
Okay.
All right. And that, I believe, the default scoring function factory is called the Karipar-Nagel scoring function factory. It was based on a paper that was written by David Karipar, who was at the time a PhD student at ETH, and Kai Nagel. And that's where these -6, -12s. It's actually a pretty cool paper on these kind of utility function parameters. And it's based on, I don't know, some specific theory.
It is in the repo.
You did on the repo. Cool. Okay. So the paper's there. I have a signed copy. And it's actually just plain normal people. David Karipar is a surfer. How are you a surfer in Switzerland? But trust me, they surf in rivers. So they're desperate to surf. Okay, so we want to bind the scoring function factory, and we want to bind it to something. Again, we can either bind it to an instance if we create our own scoring function factory, or we can bind it to just a class, which means the factory will be created as and when needed. So we're going to keep it simple and just bind it to the class, and I'm going to create here my scoring. Mind you, let me leave this empty here and start on the other end for now. So in this general project, I'm going to create a new class, and I'm going to call it my scoring function factory. Let's call it my demo scoring function factory. Right, and yes, we can add it to Git so that it's on the repository. Right, so what do I want this scoring function factory to actually do? I want it to, and I can never remember when do you extend a class or when do you actually implement a class, interfaces versus abstract classes. So I'm just going to say extend the current one. So I want to extend the normal scoring function factory. And it'll come back and it'll complain, and it will say, no, that's wrong. And if I hit Option Enter in IntelliJ, it suggests what it should do, and it says, you know what, I think you should change the extends to implements. Say, okay, you know better. Oops, that's what I wanted to do, but there's still an error. I check what the error is, and it says there are unimplemented methods. I say, okay, I will do that. And it creates this method for me that must now be implemented. And the method is simple. I give you a person, and you create a new scoring function for me for that person. All right. And that's what the factory does. The factory says, here's a person, give me a scoring function factory. So if you want to score everybody exactly the same, you can write a scoring function factory that returns a fixed value irrespective of what happens in the model. Right? That's possible. Probably not very useful, but it's possible. All right. So at this point, let's just return null. We'll do this just now. Go back to my module, and now we can bind it to this class of mine, my demo scoring function factory dot class. So now the controller knows, okay, there's a new kid in town. This is what you use if you want to create scoring functions. And I'm going to keep it very simple because that's all I know. And I would suggest that this is what you stick to, because I cannot foresee that any one of you will need something any grander. And what we have here is, I need to go and look at some example code, always, because I never memorize these things, is what we call a sum scoring function. So we're just going to call this scoring function, let's call it just SF, is new sum scoring function. And all this does, it takes all of the little bits and pieces. What parameters are there? Nothing. Oops. It just has a, it just sums stuff together. So you have a container that's a scoring function, and you can add to the scoring function whatever you want. If you want to add time, you can add time. If you want to add money, you can add money. If you want to add distance, you can add distance. And it must be able to know what, it just sums everything up. All right. And that's ultimately what is the default inside MATSim as well. But it looks somewhat different. So for that, let me go and look at an example, which would be in the MATSim UP organization. Come on. There it is, in MATSim UP. In the vehicle ban class, which most of you will actually use, let's go to the equal network. No, this is clearly not the latest one. Oh, sorry, this is test. I'm in the wrong one. Test main vehicle ban. There's a vehicle ban scoring function and a vehicle ban scoring function factory. So if we're going to have a look at the factory, you'll see it does the same thing. It creates the sum scoring function, which is what it ultimately returns, and it creates scoring parameters. Now these scoring parameters are just the default parameters that are created by default for a person. That's what we call the marginal utility of time. How much worth is an hour to you in monetary terms? How do you convert money to money? How do you convert time to money? How do you convert distance to money? How do you kind of all these marginal utilities? Or actually no, I'm explaining it wrong. It's a marginal utility. So how much utility is a kilometer or a meter? How much utility do you earn or lose from 1 minute, or in this case a second in MATSim? But money can be converted to utility as well. So how much is a rand worth to you in terms of utility? How much utility do you get out? And that's the econometric way of bringing all these different units of measure into the same thing called a utility. All right, and these parameters, these marginal utilities, are kind of standard. And I always need an example like this to just show me where do I actually get these parameters. And then in my sum scoring function, I just add some scoring functions. I have a scoring function for the activities. So what this will be is the time that I actually spend doing a useful activity. So going to work, going to home, going to whatever it is. What's the marginal utility? I add a leg scoring if there's a specific leg that I want to score in one way or another. I've got the money scoring, and in my case I wanted the agent stuck scoring as well. If an agent is stuck and it cannot move in the network, which I used in this vehicle ban to say a truck is being pulled over and it actually now is stuck for a while, what actually happens in the process? I don't think it's the best way of doing it, but that was the workaround at the time. And then, and you can add more scoring functions to this sum scoring function of yours, but I revert back to the default Karipar-Nagel scoring functions for activities, for legs, for money, for agents. And these are the things that are covered in the book quite well if you go to this portion. And that comes from, there's the Karipar-Nagel function. So how do I calculate utility? Well, I take the marginal utility of waiting time multiplied by the waiting time. So the marginal utility of money is measured in 1 per rand, 1 over rand. The marginal utility of time is 1 over second, to just get rid of the unit of measure, because utility is unitless. And these things must be able to just be added up in your scoring function. Right. So let's just see how we do that again. New scoring parameters, builders. Okay. So in IntelliJ, we have scoring parameters. Params is scoring parameters dot builder. We actually have to instantiate it. New scoring builder. Oops. What are the parameters? It wants a scenario and it wants a person ID. In this case, where do we get the scenario? We have to inject it, because we're in the scoring function factory. So this factory will only be called during the simulation run. So we should have access to the Google inject scenario already. So we can just say scenario, and we get, for the person ID, we just take this person that is passed to this method create new scoring function, and oops, say dot get ID. And is that the same? Yep. So now we have the builder, and come on, and we can run the build. So this first portion creates the builder, and this is, I'm not sure whether you learn these things explicitly in some computing course, but there seems to be 2 approaches, which sometimes gets mixed up because we use libraries and kind of different schools working together. You get this thing that is a factory that creates something for you, or you have this notion that people have these things that they call builders, that you set up all the parameters in the builder, and once everything is set up, you say, okay, I'm ready, now build it. So those seem to be the 2 different schools of thought.
If you Google design patterns, because they classify as design patterns.
Design patterns, okay, cool.
So they're just different ways that address different problems. But I know builder and factory are very, very similar.
Yeah. So you can also configure a factory, and then later on when you say, okay, create this thing for me, it looks at all its custom set parameters, and the same with the builder. You can build this builder. So there's some advantages of working with builders. If at some point, maybe that's a topic that we can actually have for a next session, because I actually find the builder design pattern pretty neat.
I think it has more control over the factory.
Yeah.
That's one of the
So we can look at an explicit example, but what you often find is that they use a notation where any method in the builder always returns the builder back. So when you say set name, it sets the name and gives you the builder back. So you can literally code something like my builder dot set name, and you can actually set the name. And this method will return the builder, which means you can immediately carry on and actually say set coordinate, and you can set the coordinate. And this set coordinate method will return the builder again, which means you can go dot and do the next thing. Set some parameter, dot set some parameter, dot set some parameter, and you can carry on until in the end you say build, and voila, it actually builds the whole thing. All right. So now we have the parameters. So now we just add all these scoring functions to our sum scoring function. So we say sf dot add scoring function. We need to work with some scoring function here. Sorry, let me rather look on my own screen and not at the top there. Add scoring function, new Kariparnagel. There's our activity scoring function, and it wants parameters, just those parameter settings. We add another one, sf dot add another scoring function. We create a new activity scoring. Activity scoring, we've got money scoring, agent stuck scoring, open times, activity scoring, activity agent. What others did we have in there? Activity leg, money, and agent stuck. Karipar. Leg scoring, and it wants parameters, and it wants a network, which we get from the injected scenario. Add the scoring function, new money scoring. It probably also wants the parameters. Yeah. And in this case, I'm not going to even add the stuck one because I don't think we actually need it. Right. So what this does, it creates, or this is the factory that must have a method that says create new scoring functions. So every time that the code wants to create a new scoring function, it will call this little class, and this is how it will go about doing it. If there is nothing for agents being stuck, then stuck agents will just not be scored. It will not have a benefit, but it will also not have a this utility. If somebody is stuck, it's stuck, 0 score. All right. So if you want to build your own scoring function, you first need to actually have a scoring function factory that you need to set up. And we can actually make this package private because it's only the module that need access to this. Nobody outside should be able to use our scoring function factory other than ourselves in the module that we actually built. So we'll try to keep the footprint as small as possible. All right. Now let's assume that over and above, you can go and have a look at what goes on inside each one of these scoring function factories, these scoring functions. So there are money scoring, and essentially what this does, it has a method that says add money, and what it will do, and you give it an amount, and what it will do is it will take the current score that is being passed to it, and to that it will take the rand value and multiply it by the marginal utility of money. So it will say, right, you say that this guy paid 10 rand toll. It now converts 10 rand toll by multiplying it with the marginal utility of money to some unitless utility, which may be positive or may be negative, and that gets added to the overall score. And this is how MATSim in the end knows what's the overall single score for an agent. As the events happen, events add money. Now the guy had a parking fine, and now he entered a toll link, and as the model runs, these money events just gets added, and every time, because there is a money scoring function, we now know how money is actually converted. It simply uses the marginal utility of money. All right. I think what is very important to just say at this point is, please, utility, the score of an agent is not cost, it's not time, it's not distance, it's utility. So you have to work with these marginal utilities so that when you add a score, good utility is positive, negative utility is is negative, is a disutility to somebody. So cost, money out of pocket, should be a negative utility. All right. So that's why you'll see that the marginal utility of money in the config file is typically negative. So you pass a cost, money, 10 Rand toll, to this function, but because it multiplies it with a negative marginal utility of money, it becomes a disutility. And the same if you actually look at leg scoring. It probably takes the distance, if I'm not, okay, so there's a so it takes the travel time and it multiplies it with a marginal utility of traveling. If the marginal utility of travel is negative, it means it's a disutility to somebody. All right.
So at the end you sit with utility that's not unit specific and you just add it.
You just add the stuff, and that's why you can. That is why one of the most important things that at some point we have to do with the South African model is we need to estimate these marginal utilities for the South African environment. And actually they should be person specific, because 1 Rand for me doesn't mean a lot, but 1 Rand for the parking guard means a lot more. So you have individual different marginal utilities of time, of money. Well, usually we keep time similar because everybody only has 24 hours in a day. What you do with your 24 hours, how much you can earn per hour, and things like that is where the real marginal utility is actually different. But we don't know what they are in South Africa at this point. So we use the same kind of values for now.
Just in terms of zooming out again to the MATSim group, determining those marginal utility of time of traveling for South Africa, that's exactly why we have Michelle or whoever wants to work on that same kind of work.
Yep.
So if we understand travel behavior in South Africa better, we can start estimating those parameters.
Exactly, yeah. So her work will probably focus on how do people make choices in terms of a mode shift. So what's your marginal utility of a transfer? Why do people like to transfer or not transfer or things like that?
Sorry, so just a technical question. Can those parameters be changed on the fly, like while MATSim is running?
It will probably lead to very erratic behavior. It is probably possible, but I can't see why you would want to do that. What you would rather do is for every person, rather add an attribute and use that person's attribute for that person's.
What I'm thinking of is like if someone's late, then the utility for travel would be, well, the disutility for the distance of travel would be greater. If that makes sense.
There's a different activity called waiting. And there are different marginal utilities for waiting, for being late, for actually being early as well, because that's lost time.
That makes sense.
And there's actually, I mean, if you're interested, that Curry Paranagal paper goes into that quite a bit. So the marginal utility of being, I think, late and being early is 0, which means there's no disbenefit. But what you actually find is that the disutility is in suddenly you have 1 hour less work time. So you don't have the opportunity to work and earn money for 1 hour more. So you're not late, you just lose the opportunity to actually earn money. There's a whole science in terms of the travel behavior that just boggles my mind. All right. So what we did in the vehicle ban as well is we created our own scoring function portion. And what that class actually does is you need, whenever you implement your own scoring function, there must be something that says finish, which means, okay, I'm done now. How do I actually kind of what should be done when I'm finished? And there can be a whole code that you either write it out or to file or do some more calculations or do a bunch of checks. What I've just done here is Okay, just to give you background, the vehicle band works in a way that if you enter a band link at a band time and you are a banned vehicle, it just flags you in terms of the person's attributes to say you have entered a banned link. And then there is some probability that then also runs at that link enter event that says, are you caught or not? And if you are caught, you should be fined. And this is what I do here. So I get the plan, and I get the fine from the config group, which is something I believe we looked at. No, it's something we will have to look at today, we said. So I get the attribute. Are you, or have you traveled on a fined route? And if the answer is not null, I actually convert it because that is a true false statement. Sorry, are you on a banned route and are you fined are two separate ones. So here I just check, are you fined? And if you are fined, so if that evaluates to true, I return. Remember, I get the score. So what I do is I from the config file, I actually get what is the fine that you're supposed to pay, which is a rand value. I take the negative of that, and this is actually wrong. Do you?
Yeah, marginal utility is negative.
Because marginal utility of money is already negative. So I need to check what fine when caught is, whether that was actually positive or negative. That should be positive. Then this code should actually be negative. Okay, so I just need to check, yeah, but the score should be a negative value because it's a disutility. Otherwise, it just returns 0 if you're not a banned person or you weren't fined.
Where's the probability of being fined? Where does it implement that?
That's in a link enter event somewhere. So the link, whenever an agent goes into a link, there's a link enter event listener that checks, is this a banned vehicle, is this a banned link, is this a banned time of day, and if they all evaluate to true, it flags the agent to say you've used a banned link, and then there is a probability that says...
So that probability is in that other...
Yeah.
Okay.
And once you're fined, I assume that for a leg, you're fined. You can't get fined twice. If you drive around with your fine that says, I have already been fined this morning, I now need to just get off this highway, please. So you can only be fined once per trip, not once per day. Right. So going back to IntelliJ, we've got a scoring function factory, but we may want to add our own new scoring function, which then my person let's call it my erratic scoring function, and this implements scoring function. So it will complain and it will say you have to implement the methods. Whoops, there's a whole bunch of them. It wants to know, how do you handle activities, how do you handle legs, how do you handle... Okay, so if you have a basic, just a scoring function, you can add all of this in one class. Money, distance, legs, activities, all of it in once. Or you can have a money scoring function which only looks at money, one that only looks at legs. So if you just have, in this case, a basic scoring function, it will handle all of it. So handle activity, what will happen? Nothing. Leg, nothing. Agent stuck, nothing. Add money, nothing. You can add your own stuff in there or get score. Here it always returns 0. And if I really want an erratic one, I can say, get me the MATSim random, get me the random instance, next double, which is between 0 and 1, multiplied by, let's say, 10,000. So what this will do is, for every agent, it will randomly just, let's make that negative, it will randomly just get a value between 0 and 10,000 and use that as a negative utility for the individual. Right, but this is completely, that's why I call it my erratic scoring function. It's not based on anything useful. So let me just refactor that. My erratic scoring function, and if you want to add this to your sum scoring, you can just add it here, sf dot scoring function, my erratic scoring function, and it doesn't take any arguments. Oops, does it? New, yeah. Oh, come on. Okay, that does not seem to like what I've done. The sum scoring function cannot be applied to my erratic scoring add scoring function. I have a scoring function, but I probably need to implement a sum scoring function specifically, which means I won't need that, and I won't need that one, and I also don't need that one. Oops, that was dumb. Let me just start over and see what do I need there. Sum scoring function. Get rid of all of this. Ah, come on.
Is it something about base sum scoring function?
Basic, yeah. I'm not sure whether it should be a basic. Well, let's at least see what happens in probably should be extends basic. Change to implements, and then it wants to implement methods. Okay, so within the sum scoring function there seem to be subclasses, of which basic scoring is one. So within the sum scoring function there's a basic scoring which only does finish and get score. There's activity scoring which probably does finish, get score, and handling the activity. There's agent stack, arbitrary event scoring, leg scoring, and money scoring. So within sum scoring function factory, you've actually got those three different ones. Sorry, three, a bunch of them. Those. So if we just stick to the basic, this is where we will then have our minus MATSIM random. Right. Good. So you can have your own scoring function, If you want to implement it, you have to also implement the scoring function factory, which then gets bound to the controller. But there can only be one scoring function factory per MATSim run. Yes? Cool.
And that's why you use this in your module.
You don't have to use the this. I think it's kind of good coding practice to actually use it, but
Just tell yourself there's only one scoring function factory.
no, it's just to illustrate that inside this controller there are add ones and there are bind ones. But I mean, I can take that out without any loss of functionality, because it still knows that it belongs to this current class, this abstract module. Cool.
Okay.
So can I just quickly ask a funny problem? I'm getting an error with my, say, inject my demo scoring function. It says annotations are not allowed here. The Alt Enter only gives me remove the add inject.
Just check your inject. Are you using com.google or are you using JavaX?
I'm using the Google one.
Just check.
I think that's causing
Okay, but you've got scenario.se, that should be a space.
so.
All right. Can we move on?
Yes, clear as mud. Mud.
All right, so we said that if we do this properly, we should still be able to now just run this class and it should run without errors. Let's see whether that, it compiles and it runs. We don't know, well, we can actually, it will run because we don't have any people. So we,
School.
so we can't score them. So you probably have to add one person at least.
If you say now we want to go play around with even just the equal network and change scoring functions, then the only way for us to see is to actually at the end also write out stuff for us to go look at, did this change anything?
Yeah.
Yeah.
And I mean, this is where the all my controller listeners become useful, because at startup event you can create 10 individuals, give them plans that start at one end of the equal network, move to the other end of the equal network, and in your shutdown you can now read your executed plans, your selected plans, do your analysis, whatever you want.
I think that's the next thing I need to do in a tutorial for the VIP group is once you change things, how do you then determine what changed? Like how do you look at the results, the outputs?
But I mean, it's what we teach in simulation as well, and that is that I think it's hard if you just code for the sake of coding, of learning. So you have to know, why did you run this model? What in the equal network do you want to check? Because that will determine what analysis you actually do at the
Right.
end.
So if you want to just change scoring and make impatient and patient people in the equal network, just to see if you can make scoring work,
Yeah.
and then how do you check that?
I mean, for this shutdown, you can go and run through your persons and actually say, get the score, check the minimum, check the maximum, and just report the min and
Spread it to
max.
the console.
Just spit it out as a log message at the end of the day and just do that. See if you can get the minimum and the maximum. And the more people you have, the closer you should get to 0 and 10,000 in this kind of example of ours. All right. So yeah, there's our message of last week, found 0 people, or 2 weeks ago.
What's that movie with Will Smith when he's the only one left in New York? Yeah, found one person. And it's
Alrighty. So that's the scoring function. Easy if you know where to look.
How many years was this?
It's still ongoing, so I haven't stopped counting. All right. So the other thing that I became a big fan of very recently, as in December, January, because I became tired of, where is, doing a hell of a lot of code here on the initial demand side and then throwing it into a controller and hoping for the best. So MATSIM has this config file that all of you have been playing with and fiddling with and changing values with. What I'm going to show you now is how you can actually create your own config group so that you have your own config file. And let's call this my demo config group. So inside the config, it was an XML file with different sections. One was called plans, one was called network, one was called controller, global. There's a whole bunch of them, plan calc score, plan calc root, and we're now going to have one that is called, the class is going to be called my demo config group. Right, and we're going to add it. And I think this is an extends version if I'm not mistaken. And this is reflective config group. That's what we're extending. And no, it is. You just have to create a super constructor or constructor of the super, and you must give it a name. And to keep things simple, I always want to be able to call this thing by one standard name, come hello high water, so I don't want to remember what it is. So I'm going to create a public static void string that is going to be called name, and the name of this thing is going to be called demo up. Public static, not void, sorry, just public static final string. And that should be inside the class. Right. And there's a constructor that just calls, that can be, let's keep that the same because it must be the same, but here we override it and we just call name. All right. So that's a constructor, that constructor must be there. Now this is usually easier if you look at how somebody else have already done this. So let me start by just let me explain the context. Why do I want a config group? I want to write a piece of code, and at some point I want to give it to students and actually just say, run this with the following parameters. And I don't want them to mess in my code. I want them to only fiddle with a config file. So they must change the 2 to a 3, and then to a 4, and then to something else, and then to something else. And they must only interact with my code using the config file. But for that, I need my own config group, and it needs to know what these different values in the config file actually is. And that's what the MATSIM group created this reflective config group for. So now I can add, let's say, 3 parameters. I've got a private double, let's call it time to rest. And it might have a default value of, let's say, 1 hour. And private int number of friends is 5. And let's say private string social network file name is sn.xml.gz. So 3 different types of parameters that I want to be able to set. How long are my agents allowed to rest? How many friends do they have? And a file that might be an XML file that reads in your social network for every agent. So what I'm going to do is I'm going to create getters and setters for each one of these private parameters of mine, which means I can get my number of friends, but I can also set my number of friends. I can change the config, these config parameters as and when I want.
So those values at the top are only just the default values?
Those are just the default values, so that it's not null. You can have null values in there if you want to as well. Happy?
So do you have the shortcuts for the getters and setters on the group?
I stand on the variable name, and the same as what you do for the not autocomplete, the hints. I think it's Alt Enter in your case, and then you should have add getters and setters, or just getters or just setters, and that's why I actually make these variables private, so you cannot access them directly from the outside. You have to set them or get them via these methods. All right. Now, the one thing that is not that simple to kind of know what it should look like is these comments that you actually find inside the config file. So when you open a config file, you will see that somebody has written comments there that says the allowed values are PT, car, walk, ride, or whatever it is. Or if you choose curry parnagel, this will happen. Do you want Q? Do you want QSIM? What do you actually want? So these are the methods that will be shown inside your config file when you actually write it out. So the better you document this, the easier it is for other people to actually work with your config file and your config group, your specific module that you actually want to work with. Now, what bothers me is, why is there a public map string? Why is there an override method, but it never asked me extend reflective config group, and this is extends reflective config group. Okay, don't know. But we're going to add that method for ourselves now. And so this should be public. Is it public? It is a map. No. Of strings and strings. And it is get comments. I'm just going to copy this first line from UP. Now I actually have the comments, if there are any kind of super comments that comes from the reflective config group.
So when I added the public map string thing, it added an override on top.
It did?
Yeah.
Now I probably get comments as mine.
So that override was also added to mine.
Okay. Mine didn't. Oh, there it is. It actually says that there is, but it didn't add it here. Why not? And here I just have to say return comments. It says that it overrides that method, but it doesn't add the override tag for me. I wonder why. Okay, so it picks up that it's actually overriding it. So what I've kind of learned from other examples is that each one of my these final static strings are just what do I want these parameters to be shown as in the config file. I call them fine and probability and stuck. So for me, it makes sense that the text associated with them are very similar to what I actually want, what I use them inside my file as well. So I'm just going to add these names in here. Are they public or final? Or are they just final? Final statics. Yeah. Static string. And I'm going to call this time to rest is time to rest. Final static string number of friends that I just overwrite my own stuff.
Yeah.
Number of Okay, so I'm going to keep that third one a little bit simpler. And inside this map, I'm just going to add comments dot put and time to rest. I can say specify the number of seconds of rest. And comments dot put size of social network to consider for a beer, and comments dot put file name of the social network. Right, and then I've got my comments. Now to link these comments to the variables, what I need at each one of these strings is a method that is called string setters and string getters. And I can never remember, this is no, not here. At each one of my getters and setters, I now need to put in, this is get time to rest, so I'll put in a string getter. And I want to link this to time to rest. This one is string setter for time to rest. This one is a string getter for number of friends, string setter for number of friends, string getter for social network, and string setter for social network. Right, and this should do the trick. What this kind of is helpful is if you're going to run a scenario with many parameters and you need to test different parameters, it might be useful to have one of these config groups, and this is how you now set up your your experiment. So when you're going to create a module, you might create your own config here.
Sorry, can I just pause? Is this now when you want to create new parameters in your config file, as opposed to just changing the parameters of what's already in the config
Yes,
file?
if you want to create your own little group inside
So
and
the own little, in the XML, your own
and your own
little-
XML file, there should now be, or when we write it out, and if you've connected it, there should be a module, and we'll check whether that happens just now, that is called demo UP.
MOUP. Okay.
And it
has
will
different
have,
parameters.
and it will have different, those 3 different parameters. So if you then give your config file to somebody else, you can say, you don't have to mess in my code, run this class, and change the parameters inside the config only. All right, but now you need to tell the controller that there is this config group inside its config. I think, at least for me, what would make good sense here is when you create this constructor, at this point it's got a default empty constructor, so I'm just going to create a public my module, which is the constructor itself, and I want you to pass a my demo config group during its constructing phase, and I'm going to create a final my demo config group called config group, and you will set this during construction. All right, so when you create your own module, the one that we've created last week, you must pass it this demo config group of yours. And then when you actually install, when you're ready to run your MATSim run, you want to add this config group, which would then be config utils dot add or get module, and it takes 2 parameters. It takes a config and it takes this module that you actually want to add. Where do we get the config? Well, this is the controller, and the controller has a method that says get config, and the second one is this dot, oops, no, it takes module class, sorry. So it will be how do I connect this explicitly? Can't think of an elegant way, so let's do it the following way. I want to just link it my config group dot name. Yeah, it needs a class dot class. Question now is, how will it get that values from this config here to the config in this install file, because these aren't linked and I can't pass an actual instance. Mind you, I can. Do you remember when we run this, that right in the beginning of the module, this install is called 4 times? Which is a problem. Okay, let me show you kind of how I figured this out, because this was not by memory. I stumbled across this by accident. There's a method that says add plan. No, there is a method that says get config dot add a module, and I can add this config group, which is this instantiation which is now already created. Let me take this part out. Okay. So now if I go to run my model, where is my run Matsim with logs? I cannot create a new module unless I actually have a config group as well. So I first need to create my demo config group. My demo config group is new my demo config group. It doesn't take any arguments, does it? Apparently, oh, come on. Apparently it does. It wants a name. So let's give it no, I don't want that constructor. I'm going to make that one private.
Can you not just take out the name parameters from the constructor?
Yes, you're right, because I don't really need that. I can take it out there and still create the super, but the super must always be created with a name that I actually provide. So now my demo config group does not need a name, and now I can do all the magic that I want. I can set the number of friends to 10. I can change, set the time to rest to time.pass and say it should be 12 minutes and 35 seconds. I can set all the parameters that I want to run this module or this specific run with. And then in my module, I just pass it this config group, MDC. Right. What am I doing? Right, so when I create my module, I give it a config group, and when I have the config group, during the install phase, it will actually add it to the config, the one that I actually passed it. The problem now is if I run this, it actually crashes. And the reason why it crashes is because install is called 4 times, and by the time that it gets there the second time, it crashes saying, but listen, this module already exists and I'm not allowing you to add the same config group. Now, I cannot tell you why MATSIM calls install 4 times on a module. That I don't know. But what I have done is to actually do a check here. In some classes, I've actually done this kind of differently. I do a check and I say, what did I do now? I want to go back to, I do a check first and I say if no, what do I do? Get config dot get mod. Okay, I can't get a specific module anymore. Get modules dot contains a key, and that is the name, and that would be my demo config group dot name. So I check that list of modules that are in the config, and I say that if this module already contained or is contained in there, then it should do something, but I actually want to negate this. So what I'm saying here is if my config does not have my demo config group already added, then add this module. And then I can take that part out. So the first time that it runs through, it will not get my demo config group. It will add it and it will carry on. The second time when it calls install, it will find it and it will actually skip adding this new config group. So this should now run without a problem. All right. So let's just check whether it added what we wanted. If we go to this config dump somewhere in the log, there should be one that's called demo UP, and there's our values, the ones that we changed. 10. We haven't overwritten social network, so the normal file is there, and time to rest is set as 755 seconds. Right. Good.
So again, could you just show again our MATSim where we set parameters?
In the config or in the main run? Yeah. So we instantiate, we create a new instance of my demo config group. I call it MDC. And remember, inside that config group, we created all the getters and setters. If you want to add more parameters, you can add more parameters, and you can just create getters and setters for them. There's actually a nicer way, but I can't remember how you print out. I actually think it has something to do with time dot no. There's a way that you can actually, in your log message in the end, get this time to be printed out in a nicer way, similar to, for example, let me find it.
Is there no variable type except to double that towards variable time?
No, there's a function called in MATSim called time.print time, and you give it the seconds, and it writes it into a nice format. Well, I can probably check my own code spot on the config group. No, that was the right one. One stack. No. I can check at some point if we want to kind of play around with that, but there's a way that you can write the time in a prettier format and not in the seconds itself. Mind you, it seems everything here is set as double values. All right. So why this for me is useful is though so that you can simplify your main methods where you actually set up your experiments, be it emissions, be it vehicle ban, be it whatever it is, so that you've got one place in your main method where you say, here's my config group, here are the parameters that I want to run now, go, run. And you set it in one place and kind of the magic happens.
So it's all for the sake of reproducibility of the
Yeah. So, yeah, so that you don't have these classes that are 200 lines worth of code that you're trying to decipher, but where did I create the population, what parameter did I use, so that you can actually check your config file that is produced with the output, and you can actually see, if I go to my module here, to demo UP or to my vehicle ban or whatever it is, I should be able to read off and reproduce that entire simulation run by just reading and seeing what the values were inside this module of mine. Good, that is it. So we can hang around with that code, but I think those are the three things that I wanted to talk about today. Scoring function, config group, and then just recap that Google Juice binding.